Welcome to Earthquakes. Our objective today is going to be understanding the causes of earthquakes and also locating the epicenters of earthquakes. So there's actually people who get paid to find the epicenters of earthquakes. People who get paid to find out how large earthquakes are. And this is a study, this is a science, it's known as seismology, and the people who get paid to do this are called seismologists. And of course this map should look familiar. It's the world map. And the question is, where do earthquakes occur? Most earthquakes occur near the edges of tectonic plates. Each one of these red dots that's on the map represents an earthquake. And the question is, what causes earthquakes? Well, if you remember, plastic deformation is when rocks deform, but they do not cause earthquakes. This is when you have a folding but no break. Now, elastic deformation is when rocks stretch and bend and they eventually break and release the energy. This is what causes earthquakes. It's similar to a rubber band that has been stretched too far and then it snaps. Elastic rebound is the sudden return of deformed rock to its original shape, thus giving you an earthquake. So let's take a look at a graphic here for elastic deformation. We have a green field, we have a little picket fence running through the field, and the red arrow is representing elastic deformation. It's bending, it's bending, it's bending. Oh, it breaks! And of course, when it breaks, the fence goes out of alignment, and the sudden return of the deformed rock to its original shape gives you the earthquake. Now let's take a look at fault boundaries. We've got certain motions that go with certain types of faults. We have a convergent plate motion where the plates are coming together, that's a reverse fault. We have divergent plate motion where they're going apart, and that's a normal fault. And we have a transform motion where they're sliding past one another, and that's considered a strike-slip fault. Sometimes it's better just to take a look at a picture. Here's a reverse fault. It's a convergent boundary. This is when the plates are actually coming together. That's known as a reverse fault. And then if we take a look at a normal fault, it's a divergent motion, which means that they're moving away from one another. So they're moving away from one another, that's a normal fault. And then of course we also have a strike-slip fault, which is a transform boundary. This is where the plates are rubbing past one another. Now we're going to start talking about the energy that is transmitted through an earthquake. This is known as seismic waves, energy released by an earthquake that travel through the earth. And there's two types of body waves. The first is a P wave. It's the fastest seismic wave. It always arrives first. I always remember that primary waves are P waves because it starts with P. Primary wave motions, it rocks back and forth in a straight line. It squeezes and stretches the rock. And on a seismograph, you can actually see the primary wave. See where the blue arrow is? That's where the primary wave is actually the very first wave that shows up, the energy source on the seismograph. The first one's the primary wave. S waves are the secondary wave. Starts with S, secondary wave. That's easy enough to remember. The S waves move from side to side as they travel throughout the rock. It's actually represented pretty well on this graphic. See how it's sort of like a squiggly line there? These waves move the rock up and down, side to side like a snake. Then secondary waves, as you can see on the seismograph, it's the second source of energy that shows up to the seismograph. So this is the red arrow, whereas the P wave was the original. Sometimes it's better just to take a look in a diagram. Compare the two waves. P wave is like a compressional wave. You think of it like a slinky going back and forth. An S wave is more like a transverse wave, which is much like a rope as you jiggle it in your hand. Surface waves are waves that produce motion in upper few kilometers of the Earth's crust. This is what causes all the damage in an earthquake. They're known as L waves. And as you can see with the green arrow, they're the very large wave that shows up on the seismograph. You have the primary wave, the secondary wave, and then the green arrow is pointing towards the surface wave. The surface waves may cause the Earth's surface to go up and down or side to side like a roller coaster. So the next question is, how do we measure earthquakes? Easy, we use a seismograph. And that's what is pictured in this graphic. Instruments that used to record seismic waves are called seismographs, and on the seismograph is a seismogram. This is an example right here. You have a P wave, which is the blue arrow, the secondary wave, which is the red arrow. And as you can see on this graphic with the red star, it says we must have 3 different locations of seismographs. So let's take a closer look here. Locating the epicenter of an earthquake, we need 3 different locations. We have station 1, station 2, and station 3. And what they do is they pick up the primary waves and then they pick up the secondary waves. Once this information is received, the scientists, and what are they called? That's right, seismologists. They use the S&P times to pinpoint the epicenter of the earthquake. Now you're probably wondering, how do they do that? Let's take a look. So the scientists use the seismograms to see the difference in arrival times of the primary wave and the secondary waves. The primary waves will obviously reach the seismograph first, but we're interested in how long it takes the S wave to arrive after the P wave. The longer it takes for the S wave to show up on a seismograph, the further away the earthquake must have been. Seismologists can use the information that they receive off of the seismogram to find both the epicenter, that's the point of the Earth's surface directly above the earthquake starting point, and also the focus point, which is the point inside the Earth where the quake actually began. So if we take a look at a map of the United States, we have 3 different stations. We have Portland, we have Salt Lake, and we also have one in Los Angeles, California. And if we use the time between the primary wave and the secondary wave, we can then convert that into kilometers away from our stations. And if we draw a perimeter around each station, we actually have a crossing at the epicenter, and it's shown to be in San Francisco in this example. Now, almost done. Earthquake strength is known as magnitude. That's simply the strength of an earthquake. And finally, we have intensity, which is the amount of damage caused by an earthquake. I know this was a lot of information. You can always go back with the video, replay the video, take a look at it, watch it over and over and over again, and then get ready to take the quiz. Have a good day.